Welcome to Study Loop.
We can say that the apex angle of the prism is going to be phi, and this is equaling 60 degrees. And we have the the refractive index of the prism, n equaling 1.6. So we can say that for part A, if the ray has to minimally exit the second, then at the second surface incident angle, that should be the critical angle. So we can say that we can first say that we are going to let the incident angle at the first face be theta sub I, and this would be refracted at the first surface. This would be theta sub R. We can say that theta sub C would then be the critical angle, critically incident angle at the second surface. So now we can use the Snell's law of refraction. We can say sine of the critical angle would be equal to 1 over n, and so the critical angle sub C would be equal to arc sine of 1 over 1.6, the refractive index of the prism itself, and we find that the critical angle is 38.68 degrees. At this point, we know that theta sub C prime would simply be equal to 90 degrees minus theta sub C. This is going to be equal to essentially 51.32 degrees. We can say, similarly, we can say that theta sub R prime would be equal to 90 degrees minus theta sub R. And we can say that phi plus theta sub R prime plus theta sub C prime, this should be equal to the total angle in a triangle, 180 degrees. We can then say that theta sub R prime would be equal to 180 degrees minus 60 degrees minus 51.32 degrees. This is equaling theta sub R prime 68.68 degrees. And so we can say that the refracted angle theta sub R would simply be equal to 90 degrees minus 68.68. This is equaling 21.32 degrees. And then we're going to apply the angle of refraction for the first interface of the prism. So we can say that sine of theta sub R would be equal to n sine of theta sub I. And so theta sub I would be equal to arc sine of 1.60 times sine of 21.32 degrees. This is equaling 35.6 degrees. So the smallest angle of incidence at which the ray can enter the left end and right end of the prism is going to be theta sub I. Again, 35.6 degrees. This would be our answer for part A. For part B, we now need to apply the Snell's law of refraction to the path of the light ray that passes through the prism. So we can say here, where the light ray would now, for part B, be the same path as part A, but now we have an angle here. And this angle right here would be considered theta sub 1. So for part B, we have that n sine theta sub 3 would be equal to sine of theta sub 1. And so we can say that theta sub R prime plus theta sub 3 prime plus phi equals 180 degrees, and the total angle measure in a triangle. And we can say 90 degrees plus theta sub R plus 90 degrees minus theta sub 3. My apologies, this would be minus as well. this would be plus the apex angle of 60 degrees. This is equaling 180 degrees. So this means that theta sub r plus theta sub 3 should equal 60 degrees. And we have that angle sub 3 is equaling 60 degrees minus theta sub r. And so this equation right here, we can now substitute and say that sine of theta sub 1 equals n sine of 60 degrees minus theta sub r. And we're going to use a trigonometric identity. We know that sine of a minus b will equal sine of a cosine of b minus cosine of a sine of b. This is simply a trigonometric identity. So we can say sine of theta sub 1 would be equal to n times sine of 60 degrees cosine of theta sub r minus cosine of 60 degrees sine of theta sub r. And so we can say that this is going to be equal, sine of theta sub 1 would be equal to n sine of 60 degrees times the square root of 1 minus sine squared of theta sub r. And this would be minus cosine of 60 degrees sine of theta sub r. And we can say that we're going to substitute, we're essentially substituting this equation and this equation, substituting this equation here into this equation here. And by doing that, we can then calculate the angle of incidence at the front face of the prism. So we can say sine of theta sub r would be equal to 1 over n sine of theta sub I. And so sine of theta sub I would be equal to n times, again, sine of 60 degrees times the square root of 1 minus sine squared of theta sub I divided by n squared, and then minus cosine of 60 degrees times sine of theta sub r. This would be times. And we can then solve for sine of, theta sub I. Theta sub I would then be arcsine of, this would be n sine of 60 degrees divided by the square root of 1 plus cosine of 60 degrees quantity squared plus sine squared of 60 degrees. And at this point, we can just substitute in for the refractive index, and the refractive index would be 1.6. So theta sub I is equaling 53.1 degrees. This would be your answer for part B. That is the solution. Thank you for watching.